All right, I apologize. I give up. I've been trying for a day and a half to get this to work properly, and this is the closest I can get. So we're going to go with this since I'm running out of time. Okay, so here we have the 6 acoustic parameters of voice production. We have maximum frequency range, speaking fundamental frequency, the maximum phonation time, maximum intensity at various fundamental frequency levels, periodicity of vibration, and noise generated by turbulent airflow, amounts of spectral noise. Okay, so these are the 6 categories that he used to describe how someone produces sound. So I chose from the Rainbow Passage. Since then, physicists have found that it is not reflection, but refraction. So that is what I use. This is what this spectrogram is showing. You can kind of see the formants there in red, the intensity in yellow, the pitch in blue. So all kind of going together. Oh, yeah, frequency yellow, pardon me, formants red, pitch blue. Okay, and so then I analyzed it, and this is what it showed me. And we'll take a look a little bit closer at what all of these are. So first one, maximum frequency range. So normal pitch has a normal voice has flexible pitch. If it didn't have that, it would sound pretty mundane. The average person has about 3 octaves. So if you look on the keyboard here, it kind of gives you a general idea, 2.5 to 3 octaves. Here the average range is between a minimum of 110 to a maximum of 420. And when I did it, my mean was 262, my average, and then the median, the middle number between those two, was 250. So yay, I'm within the correct range. Okay, and then the maximum minimal frequency range. So the model ranges, that's the normal speaking range. It shows kind of the 2 differences here depending on your gender. And as we looked in the previous slide, I'm well within those range with an average of 262, within the 175 and 295, which are typical of females. And as I said, if not, it would be pretty boring. Don't know if you guys remember this movie or not, but Ferris Bueller's Day Off. And it's going to play the clip in the other window, which I can't seem to get recorded. You can still hear. Bueller. That's a notorious scene where Ben Stein does roll call for Bueller and does it very boring, very mundane, very monotone. Bueller. Okay. Next here is the average. So this is the average, approximately 200, based upon the size of the vocal cords. So notice that goes up. Men have the longest vocal cords, which gives them a deeper sound. And children, of course, the smallest equals highest. But what does that mean? What is a normal voice? Well, it has a clear quality to it. It has appropriate pitch and amplitude. So, as we said, not mundane. It doesn't get too loud, too quiet. And pitch, remember, is a perception of how it sounds, not an actual physical number. So the pitch is within range of what you hear. They don't seem to be trying too hard to make such sounds. And then it fits the needs, emotional needs, social, occupational, whatever the situation is, it belongs to. Then, of course, we have the gender, the non-changeable stuff here. That's, well, it is changeable, but not as easily. Gender, age, your build, culture, health, personality, degree of voices, vocal sensations, region, situation. So normal is a huge, broad scope of factors that all contribute, and that makes it exciting. Every person has their own version of normal. Otherwise, we'd all sound the same, and that'd be really boring. Okay, so this just kind of shows it again on where we can see just the blue lines here. The fundamental frequency, makes it a little clearer to see. And then some other things about our voice that makes us us. We typically hear the fundamental frequency and then the harmonics built upon it, but the fundamental frequency is what we interpret as kind of the bass sound. Our consonants, the resonance. So fundamental frequency is interpreted as the pitch. So lowest frequency, that's what we hear. That's what we associate with that person's voice. The greater amplitude, then the less harmonics. There's more harmonics than more amplitude than harmonics. And everyone, even if you have the exact same fundamental frequency, your harmonics are going to differ. The ratio is going to be a little bit different depending on who you are. And every time that the harmonics increase, the amplitude actually decreases by 12 decibels per octave. Okay, so maximum phonation time. The longest time a person can stay in a vowel on a single breath of air. A child should be able to do it for 10 seconds. An adult should be able to do it for 15 to 25 seconds. If you can't, then you're probably having an airstream valving issue. Here is mine. I noticed that reaching 25 was actually a lot harder than I imagined. You can see I had nice little strength there in the middle portion, but I was kind of holding on to it. And this is after doing it quite a few times. This is the best one I got. So I need to work on that apparently. So mine was 22.38 seconds. Once again, it wasn't strong the whole time, but strong enough to count. And I did the phoneme A for that. Maximum, minimum intensity at various fundamental levels, fundamental frequency levels. So you should be able to vary the amplitude level by 20 to 30 decibels. And then I have Venstein here again, just to remind us, if you can't do that, you're going to sound a bit monotone. In normal conversation, you should have a range of about 65 to 80 decibels. And the average between men, women, and children actually is about the same. With age, it differs a little, but gender, when you get older, it differs a little bit. Basically, most people should have approximately the average. So let's see where I fit into that. Well, I had a maximum of 82 decibels and a minimum of 9.4 with a range of 72. Yay! So if we look back up here, average of 70, I'm doing good. Okay, periodicity of vibration. So mass, length, tension, and some glottal pressure creates this. It gives us our constant normal vocal fold vibration. And even though it's periodic, it's not exactly 100% periodic. To be precise, that'd be 1/200th of a second. But everyone flexes a little bit on that. It's not precise. If it's excessively aperiodic, that means the opposite. You have a rough, hoarse-sounding voice. And the way that we measure this, that we look at it, we have the jitter and the shimmer. The jitter is cycle-to-cycle variability and frequency of vocal fold vibration, and shimmer cycle-to-cycle variability and amplitude of the vocal fold vibration. Pardon me. So normal range on jitter, 0.2% to 1%. And I am a bit over on that. I'm 2.695%. So in the book, it said if someone's above normal range, something is interfering with the vocal fold vibration. Pardon me, I cannot speak. I'm stressed because it's close to the deadline and I've been trying for so long to get this to record properly. So I apologize. So something's interfering with the vocal fold vibration. So maybe that's what's happening with me. Mine is also above normal range for the shimmer. It should be below 5 decibels, and mine is 1.140. However, the book said it wasn't quite as thoroughly researched as jitter, so there's still opportunity to figure out what exactly that all means. Okay, and then the final one, noise generated by turbulent airflow. the amount of spectral noise. So our normal voice harmonic energy is higher than noise energy. Turbulent flow of airflow, laminar, it's smooth through the glottis. However, there's an obstacle when it goes through the vocal fold vibration. And the vocal noise in the glottal source, which is also called additive or spectral noise, you can have breathiness, hoarseness, roughness. So if we take a look at those, it said more turbulence is like huskiness, and then lots of turbulence is hoarseness. Roughness is described as raspy sound, perceived lower pitch. Breathiness is a vocal tone that seems more aspirated. You have that little puff of air, and then air possibly escaping contributes to this. And then hoarseness is a combination of both breathiness and roughness. Okay, so there's a ratio to figure this all out. The proportion of harmonic sound, the periodic, to the noise, the aperiodic. And there's a nice little formula. It's the harmonic to noise ratio equals 20 times log of 1 divided by noise to harmonic ratio. And so my harmonic to noise ratio was 11.195. And that is my dogs chasing each other, wanting to add to the excessive problems I've been having getting this thing recorded. So I apologize for that also. If the harmonic noise ratio is higher than the noise to harmonic ratio, the harmonic components of the voice are more prominent than the noise, and then vice versa. More noise exists than harmonics if the noise to harmonic ratio is higher. So that sums up basically the Zemlin 6 acoustic parameters of voice production. And I hope you enjoyed it.